Let's try to do this process, well, backwards. Let's say that we're given some initial information. We're given that we have foci at -1 and 0 and 1 and 0. And then we have some vertices or the endpoints at -2, 0 and 2 and 0. So can you tell based on this what our major axis is? Is it elongated along the x or is it elongated along the y? Well, notice that our foci are on -1 and 0. Those are on the x-axis. So because of that, we know that we have a horizontal ellipse. If our foci are on the x-axis, that is our major axis. So from there, we have this equation that we're trying to develop. That's the equation in standard form. So we need to learn and understand what both A equals and B equals. Well, we know what A equals because we have vertices at -2 and 0. So A is our 2 and A squared. So A is 2. A squared would be a 4. Now we need to find out what B is. But B is not listed anywhere up here. The vertice on the minor axis is not listed. However, C is listed. So we know that C, our foci, is at 1. So I can use this other equation, C squared equals A squared minus B squared, to help us solve for B squared, is ultimately what we need. So C squared is 1 squared, A squared is 2 squared, minus B squared. Solve that for B squared. So let's add B squared to both sides and subtract 1 squared from both sides. And so B squared equals 3. B equals √3, but I don't necessarily need B. I need B squared. So to write an ellipse in standard form with this initial information, I understand that it was a horizontal ellipse, meaning that its major axis is along the x-axis, so it follows that form. X squared over A squared, A is 2, so that'd be over a 4, plus a y squared over my B squared, which is a 3, equals 1. And we were able to derive the equation of an ellipse in standard form solely from understanding where our foci and our vertices were on one particular axis. You guys feeling all right about that? Feels like kind of a nice break from some of the heavy lifting we've been doing earlier.